Good morning again. So I was there in the morning speaking about something different. So today in front of me I hope we have engineering students from mechanical, electronics, electrical, computer. No. This is which year you are? Final year also. Okay. So I thought that I will give a talk which is not very specific to any engineering. So as Dr. Sojinlal mentioned, a little bit of exposure to what is ISRO and how we manage things there. This is what I want to present to you. Maybe a little bit engineering will come inside, so that doesn't matter, right? So okay with you? Or you would like to talk anything else? I am ready for anything. Okay, fine. So let me talk about the launch vehicle technology and evolution. So today we are at this road. 2017 we achieved 4-ton to GTO capability in GSLV Mark 3 starting from a very modest sounding rocket in 63. So you understand the journey? Almost 50 years. We have been working on this. And we have reached somewhere now. We have an ability to make your own satellite, launch them from our own country using our own rocket. Isn't it a great achievement? Definitely yes. So it has not come just like that. When we started in 63, Americans were already going to moon. When was the moon travel happened? Similar time frame. And we were only learning how to build rockets at that time, how to make small rockets that goes to 30 kilometers, 40 kilometers. Today, after 50 years, we have gone to Mars, and that we became successful in the very first attempt. And they are also still working like that, and we are not far from the Americans. Maybe few years we are still behind, but we don't have 50 years of gap today. So 50 years of technological gap that existed between US, Europe, we have bridged, at least in the space technology. There are many other areas where we need to build, but this is what we achieved. Now you know about PSLV. PSLV is a very versatile rocket. It can go to any orbit. It can go to GTO, it can go to LEO, it can go to Sun synchronous orbit. It has gone to Moon, Mars, sent our satellites. We sent all type of satellites, science satellites, weather satellites, communication satellites, observatory satellites, space capsule recovery, and it has such a wonderful versatility. Today it is considered as one of the most successful rocket ever developed in the world. PSLV enjoys that because very low cost, comparatively low cost, and very high reliability. So this world over people are now looking at us. PSLV means you can confidently go. So we have launched almost 250 satellites of other countries using our PSLV, in addition to almost 120 satellites of our own. But to build all this, we have such a wide technology base required. We require various capabilities, which includes design, guidance, material science, fabrication, propulsion, electronics, space explosives, integration, mission simulation, environmental testing, quality, etc. So ISRO is filled with people who have experience and expertise in various disciplines. So we recruit engineers, scientists from every discipline possible. Mechanical engineers, electronics engineers, computer science people, with BTechs, then chemical engineering, production engineering, management area, science graduates, postgraduates, PhDs, agricultural scientists, geotechnic specialists, water resources planning, ocean scientists, weather science people. All these type of people are there in our area. Cartography, imagery, special material processing. It's not only building rocket, we also have capability to convert the images into applications. We know how to predict weather. We have weather experts within ISRO. We know how to calculate agriculture product from our images of satellite. We have the agriculture scientists. We have people who understand water resources. So all types of people are there in ISRO. And to build a rocket, we need a lot of technologies. It's like propulsion, materials, and so many. And actually it all got developed in the last 50 years and we are able to keep that knowledge inside using our own people. It's not written in a book. How to design a PSLV? There is no book like that in ISRO. So if you have to design a rocket, what I have to do is I have to assemble people who have all this expertise in one room and tell them, now you design a rocket. So we have a person A has this experience, B has an experience. So they put together, they design the rocket with no written book. So all knowledge is kept within the people and they know how to do it. And this has come out of an organizational culture. So we started rocket design through a process called a launch vehicle design process, which will start from various techniques. For example, we look at the propulsion system choices and various aspects, design, detailed design, hardware realization testing, and we conduct lot of tests. Finally, we verify the launch complex and finally design at the launch pad and integrate and launch. So this process typically takes 5 years, sometimes it will take 10 years. Typically, we have been taking 10 years to design a new rocket because that process is very long. To define the rocket, then convert to fabrication drawing and then reach fabrication itself take few years. But I will show you one example how we have accelerated that 10 years just to 2 years. I will show you one example which is recently. Today in ISRO we have so many areas of specialization. For example, chemical engineering, material science people, software people, structural engineering people, propulsion, mission design, manufacturing, program management, electronics, that is avionics, aerodynamics, ordnance, that is explosives. So all these people we recruit. We recruit PhDs, we recruit masters, we recruit BTechs who can go to any of this area and then become an expert. Then they can go for higher studies in some institute, IITs and IIScs. They can also take PhD degree later and establish as an expert at the end of his career, or even while he is working also. And we work on system engineering. So we work on rocket, but ultimately we give some benefit. So I'll just explain one or two of the societal benefit we do based on the knowledge we have. So we made a limb, a leg, which is polyurethane foot. So using the material we used, developed for the insulation of cryogenics. So using that we could make a lightweight leg which can be fitted on a prosthetic leg. We have now designing currently this is going on, a prosthetic leg. A prosthetic leg is the leg which you can fit it on an amputee, which is only below this it is amputed. It can be fitted, it will work with the computer control. That means if he is walking, he can sense the walking and the sensor or the controller inside will actuate a hydraulic system which is battery driven. It will look natural. When you wear pants, you can't even distinguish whether he is actually wearing a artificial leg or otherwise. Currently the first model of this is already prepared there. So we are using the knowledge available in computer control. We are using the knowledge in hydraulics, actuation system. We are using the knowledge in sensor, electronics testing to develop such a system. We have made a left ventricle assist device. It is a valve. In case some valve in heart goes bad, this is to be fitted. It is 1 in 1 lakh case. So we have created such a device. It is again an import substitution using the knowledge in designing turbo pumps in engine. And we have made such a small pump that will pump the blood in the heart if the heart is becoming weaker. So this is also we are testing with the support of Srijitra Institute at Trivandrum. So here we need to know how to design materials which the biocompatible materials, how to design turbo pumps which will not destroy the blood cells while it is rotating, and how to design the controller by doing measurements and all that. So this is a small team is working, interdisciplinary team is working to do that. We have made a search and rescue beacon which is based on a navigation system, the GPS system. In case somebody get lost in sea, you can press a button, it will send a signal, it will be picked by a satellite and sent to a control center, and they will alert that the boat is now marooned and you have to rescue him. Or if you go to a trucking if you carry this instrument while trucking, then you can send a distress signal. So we have a global network of satellites which can actually pick the signal from this, and anywhere in the world it can be informed to its country of origin. So like that we have made plenty of technologies which is available to outside world in addition to what we are doing inside. So this is our core area is propulsion. The propulsion is a fundamental to rocket, is it not? If you have to move forward, you have to propel. You are all propelling yourself. So if I have to gain velocity and go to the orbit, overcoming the acceleration of the earth, you need propulsion. Propulsion is a technology by which that you are generating so much of energy. So the fuel which is used in rocket is full of energy. And if you burn it, very high temperatures are coming, something like 2000 to 3000 degrees centigrade. And when you expel them at very high velocity, typically Mach 5 and above, 5 times the speed of sound, it is expelled. So the rocket gains velocity. And by eating its own mass, the rocket moves forward. So this is a technology. So we have various knowledge like solids. So if you can look at solid rockets, there are plenty of solid rockets. This is the biggest one we have made, 200 tons of propellant. The grey color, what you see here is a propellant, simply cast into it, 1, 2, 3 pieces, each weighing 100 tons. Even to lift it itself is a massive effort. And we have the rocket of PSLV, which is 139 tons. We have strap-ons of PSLV, which is 10 tons. This is 9 tons. Like that we have small 88 grams rocket. So this is not the full spectrum. There are many of these types which we are designing using different propellants and different sizes for different applications. So this was used in deorbiting of the moon impact probe, which went to moon. To come back to moon and impact, this small rocket was used. And there are plenty of other rockets which we are designing. So if you want to design a solid based rocket, it is a child's play. In VSSC it will be designed in just 1 month, flat. So, but you think that it is so simple today, but I can tell you a story. In 1960s when we are designing, any motor you test, it used to explode. All this Kalam and all his friends were designing rockets and motors and items. Every day they will test, it will explode. So that means the knowledge that you have today to design in 1 month came out of that experience of explosions and failures, and we understood how it works. So today we know how to design a solid motor with just like that. The technology, the software, the processes, the methods are all well developed. Same is the case with liquid engines and rockets. So this shows the liquid engines. This is a semi-cryogenic engine. This is a liquid engine which is currently flying. It's a cryogenic engine which is used in the GSLV. This is a cryogenic engine which is used in GSLV Mark III. This engine is used in the 4th stage of PSLV. These engines are satellite engines used in our standard satellites. So the varieties of engines are made in LPSC and used in our launch vehicles and satellites. This again got developed in the last 50 years. And technology is very complex. If you look at one of the cryogenic engine which I will if you see, it is a maze, full of piping. So it looks so complex, but then its design is also equally complex in terms of power. For example, this engine develops 5 megawatt of power and it weighs only 500 kilogram. So you know 1 megawatt of power? Have you seen a diesel generator which is fitted in the generating stations having 1 megawatt of power? How big it is? It will occupy at least this much size of this podium. That is called 1 megawatt of power diesel generator. And this engine generates 5 megawatt of power in rotating speed because it rotates at 40,000 RPM and operates at 1000 degrees centigrade using gas and pumps oxygen and hydrogen in so fast. And generates 5 megawatt of power and its mass is only 500 kilograms. So you can understand the power density inside that engine. So that is the complexity of cryogenic engine. Now let me go to the management of how we manage all this. We have a system called verticals. Those who are in business field would have heard about verticals. So what are your verticals? What do you understand by vertical? It is your domain that you want to divide the total activity to different domains. So we have also divided our domains into various areas. One of the areas is called space transportation. Then space infrastructure, that includes satellites and its maintenance and operations. Space application, how to use a satellite to produce certain output. Then capacity building, how to build our institution, how to build capacity to develop new things, etc. And human space flight. So we have different centers. So each of the center, for example, space transportation is handled by my center VSSC, LPSC Liquid Propulsion Center, Satish Dhawan Space Center, and ISRO Propulsion Complex. All these 4 centers together manage the space transportation vertical. And I am the managing chairman, committee chairman of this whole vertical. So we have project management council chairman for each of this vertical. We report to chairman ISRO. So we handle the whole plan of how this has to be done in this ISRO. So we created a management structure, and that's how we handle this today. So, and downline there are so many other structures that we created. So almost 18,000 people in this organization. If you have to really produce some output, we need to create a organizational structure. So it is important. This is a new concept that we introduced, verticals. But there is the most important part is projects. You heard of Abdul Kalam, who was the first project director of SLV3, successfully made it. So this shows the project director of SLV3. He was the project director. Under him there was a deputy project director, and under him there were project engineers, and each of them did the developmental task. So we create a structure in the organization. Suppose we have to make a rocket, we immediately go and make a project team. So you are the leader, and he is the deputy leader, and these are the sub leaders, and each one is responsible for this. If you have to conduct a conference here, how will you conduct a conference? Immediately you will form a committee to conduct a conference, and local organizing committee chairman you will form, and under him there will be a chairman for catering, another for transportation, another for technical program, right? So this is essential. If you are to organize today, if you are to run a system, you need to first delineate the responsibilities, and there must be somebody who is actually coordinating and seeing where the weakness is, put the people appropriately, and then manage it. It is the essential part of any management process. It cannot be just like in a chaotic environment, nothing will come out. So organized way, and you have to find out somebody who is capable of managing each of these, somebody who is good in food arrangement. A foodie fellow will not be good in transport arrangement. So you have to identify who is the right person to do the right job. Engineers' responsibility is equally like this. You will ultimately end up in managing a lot of things in your career. So you need to understand how to manage people, how to manage situations, how to manage resources, how to manage time. This is your essential work. So what I am telling here is that we have created at that time a project director who is responsible for the first launch vehicle, and all of these people were reporting to him, and Kalam is the person who actually created a concept called review. In ISRO, before that there was nothing called review. Somebody will design, he will make it, and he will fabricate, he will test it and fail. Now, we said that it cannot be done. You are using public money, so whatever you design, you bring it to us. A team will sit, will listen to him, whether his approach is correct, whether his design can be given a go ahead. So we started creating called peer review principle. Suppose a work done by one of you, you allow that to be reviewed by somebody else of your level, not your teachers. You know what will happen? They will ask you questions. And when they ask you questions, it will make you think. And when you make it think, you will understand your fallacies, and you can correct and improve. So this is simple principle that when you subject yourself to review, you are actually improving yourself, not being questioned. So this is a culture of ISRO today. Whatever you do, you subject it to review. You open it to people and telling that I am doing this, I am doing this. Okay, you give your comments, and people give the comment, and based on the comment you become stronger, you become better, and it is most likely to succeed when generally there is an agreement that what you are doing is right. Everybody need not agree, there will be somebody will be differing, but then at that time the project leader will come, I agree with the general view, go ahead, right? So this is the way we do things, and he created a concept called centralized configuration control board. Any project to succeed, one of the important things that we need to have is control of information, control of architecture, control of configuration. You are going to build a house, you assume. You made a plan and layout and given to corporation. Corporation approved, chapa given you. After getting the chapa, you think that this room is not like, I will change it little bit, make it like this. I will add one toilet at the back. After the build, the corporation fellow will come and inspect, and he will not give you the number, no? Okay, you are not started building house, I built one, that's why I am telling you the story. So when you go, become richer after some time, you will start building your own home, and you will face this problem. So I better tell you, once you make a plan, stick to the plan and don't change it. The story why I am telling is, there is a story of a space shuttle. They 1970s they were designing the space shuttle, and they decided in 7 years space shuttle should fly. And the managers of space shuttle were so strict that they will not allow any change in the plan, and it has to be built the way it was designed. But after 2 years they realized their plan is wrong. If they do like this, it will be less efficient, and it will be very complex, it will be very costly. But the project manager's chief said, it is very important to stick to the schedule. If you make a change, I am not allowing change. So stick to the change. And finally space shuttle was made in 7 years, but now it is retired. It was one of the costliest vehicle ever built, very difficult to manage and maintain, and they realized it even before it was flown first time. So the question is, while you are in a project and you realize it is wrong, will you change it or stick to the schedule? What will you do? You better change, right? Even at the cost of schedule, because that is important. So this is a lesson. So configuration control is important even if you want to change, because you must know what was the basic configuration. Okay. But when it came to PSLV, we had another configuration called System Development Agency. This is another architecture that we have brought into the system. The project director, their deputy project in between, there were sort of system projects. We created lot of system projects. To design a solid motor, there was another project director. A project director reporting to another project director. So this is a difference. And in projects PSLV time, we created the entire ISRO infrastructure. So entire facilities came up at that time. So this is how we manage things. So we do it through the verticals, we do it through the projects. This is our fundamental. Now look at the economics. As engineers, you should learn economics. You should learn a little bit. Is there an economic class for you, subject? Okay. So you will learn some accountancy, some management, which is one of the boring subjects that you ever learned now. The teacher will go and give a lecture. Most of the time you sleep, and you study a little bit of bookkeeping principles, debit the receiver, credit the giver. Anybody learned already? Huh? Not learned yet. Okay, anyway, it is your destiny, you have to learn that. Engineering course, I think it contains this still, bookkeeping and accountancy paper. Okay, so one of the important quality an engineer requires is a sense of value. I mean money value. Anything that you touch, it has a value. The time, the material, the process has a value. You will be a good engineer only if you have a sense of cost. So in launch vehicles also there is something called cost per kilogram. We call it cost per kilogram. So what is that actually deciding the cost? The total cost of the launch vehicle and how much mass it can put in orbit. So total cost divided mass gives you the cost per kilogram. So we found that the cost of the rocket can be lowered with a heavier rocket. So if you look at the GSLV Mark 3, it is 10 lakhs per kilogram, whereas it is much higher, 16 lakhs, 14.8 for GSLV and 10 lakhs for GSLV Mark 3. So that's why we are designing new rockets. When you design new rocket, we want to make sure that per kilogram cost is actually reduced. How do we do that? It is by simply reducing the number of stages. For example, if you look at this rocket, this contains one solid stage, 4 liquid stages, then another liquid stage, and cryogenic stage. Whereas here, there are only 1, 2, 3, 4 stages, 4 propulsion modules, and 2 of them are identical, and this is also single engine, all existing heritage, number of systems are lesser, so it will be less costlier. Another understanding engineers need to understand is markets. Some of you may take MBAs later. You will also get into market, and when you are launching a product or you become an entrepreneur, you need to understand market. Like that, I am talking about the market of rockets. So if you look at various rocket builders of the world and where they are actually gaining, this yellow line is of analysis of SpaceX. The Falcon, have you heard of Falcon 9? Elon Musk? Yes? Oh, this news has not reached Kodamangalam yet. So Elon Musk is a person who is in US, he is designing and launching rockets, and he made all the money using Any idea? Amazon, no. Amazon is Jeff Bezos. Amazon is building another rocket called Blue Origin. He is also building almost 30% of his wealth he has dedicated to building rockets, and he is launching one of the biggest rocket. So Elon Musk is a person who is building a rocket to go to Mars and using the money he made using PayPal. PayPal was a financial transaction site which he designed and he sold off. Now he is fully into aerospace. So now it shows Falcon is making one of the biggest strides in the history of rocketry in private enterprise. Today in America, entire rocket is handled by not NASA. NASA is dead. The entire space is handled in the US is handled by two big companies called SpaceX and Blue Origin. They are all full of retired NASA people, but then they are making the change and they are deciding how America should go to in the future. And many other people like Soyuz, Ariane, etc., they don't know what to do today because private fellow is actually changing the way the market is now changing. So this is something which I want to tell you. So those who are interested, please read. Cost is an important thing for everything. So the cost of launching is typically 50 to 70% of any mission. Mission means why I am launching a satellite? I have to do a communication. I want to do a television broadcasting. For that I am making a satellite and I am going to launch. So I should get a revenue from the television broadcasting. So every channel fellow will give me 5 crore per year and I am selling it to some 100 TV channels. So I get 500 crore per year for next 10 years. So I make 5,000 crores. So I have to invest and make a satellite with 1,000 crores, another 1,000 crores for launch. So I have 3,000 crores balance in my pocket. Good economics, right? So if I have to do all this, I must compute my investment and return on investment and what can happen to launch, how the insurance, suppose the launch fails, is 1,000 crore is gone. So how do you invest, insure? All this becomes important issues in space. You are not simply launching rockets, but you are looking at various aspects of cost. So you should understand what all things are involved and how do you really cost the launch, how do you really find out the cost of a satellite, how do you really cost the transponder cost. Suppose Asianet wants to uplink a news program to all across the world. Any idea how much money he spends? You engineers need to know, electronics people. A television channel starting in Cochin tomorrow, to start a television channel and uplink his program and then make it available to all India, all Kerala viewers, how much money I need to spend? Very difficult question, no? But then find out some way. You are all going to become engineers, you are going to manage such organizations tomorrow. You are going to understand how it is all going to be managed. So you should understand there is a process of leasing of transponders, how much money you have to pay yearly to transponder leasing. All these are technologies. Suppose you want to run a BSNL telephone network and how they are giving data rate of 1 GB per month. What is involved in this? How Jio is able to do at low cost compared to BSNL? Anybody thought about it? You are using your mobile phones just like that, no Jio? Please ask this question. Okay, so here again same question comes, how launch cost can be reduced. So let me describe quickly some of the important elements. So every launch cost is a function of various aspects. One is its mass, orbit, etc. And customers are important. For example, if ISRO goes to Arianespace and want to launch, Ariane will give ISRO a special price. And it will not give that price to Pakistan, or it may not give that price to China. Because we are a loyal customer, we have been coming regularly for launch, so they will give a preferred cost to us. So that is called, and we give special request, market pressures. Suppose their launch is coming down, they may give low cost to us. And high reliability launch vehicles are always in demand. In Russia, there are rockets which is ready for you to launch, but they are 50% of Ariane cost, but nobody goes there because possibility of failure is very high. Though you may get the insurance cost back, but your satellite is not there, only money is there. What use? Your business is out. So you don't like to go to a less reliable launcher, you always go to a better launcher. So this all I will skip. I just don't want to speak much on cost because there are cost models, and I hope that you will learn a little bit in your management lessons on how to compute cost and how to identify cost. Everything you do, suppose you are asked to build a machine tomorrow. The first work when I joined ISRO, my boss asked me, you find out what will be the cost of fabricating this item. Poor fellow, I am just joining ISRO after a BTech in mechanical engineering. I joined and then sitting in my seat. My boss is telling me, you first compute what is the cost of fabricating this. I did not know how to calculate. I take a block of aluminium, machine it, then surface treat it, drill fit and then give. How much it will cost? Nobody teaches you in classrooms. Is it not? Nobody teaches here as an engineer, but your challenge will be to do this. So you have to compute what is the density of the aluminium, find out what is the mass per kg cost of aluminium, and if you go and ask in a shop to buy that much aluminium, nobody will give you. They will give little bigger. So you have to buy. So what is the allowance that you will give? What is the machining cost per hour in a milling machine? How much is the machining cost per hour in a turning lathe? What is the cost per centimeter square of anodizing? What is the drilling cost per hole? Any idea you have? So how to cost this is a lesson that you need to learn in actual engineering. So you must know how to create cost models of anything that you are going to work. So if you want to start a startup tomorrow, you are going to make a software and sell it. One app you are going to develop and sell it. You have to find out a cost of the business. How will you do? How many engineers you have to engage? How many hours of work that you need to develop the software? How much of testing time it will call? How much cost for hiring your Google app or any of the sites in which to upload? What are the marketing costs which is involved? And what is the feedback and the time lag? And the time lag you have to still keep your employees happy. So residence cost is involved. And finally you should say, if I click, I am likely to make this much return, avenue, advertisement, things like that. Can you understand how to create a cost model? So engineers must understand how to create cost models for every work that you do. Very important. So start learning business economics from today. If you are not reading newspapers, economic times, take it and read. Your life depends on it, not on engineering which you study here, but your ability to apply your engineering to real life problem. Otherwise you will face the problem which I faced when I joined ISRO first time. It was impossible for me to make the estimate, and I calculated some lakhs for it, but it turned out to be twice that of it in reality. So this is an error that you can make if you are not trained enough. As an engineer, you should always worry about how to reduce cost through process improvement. You know, are the cost of cars increasing or decreasing? Cost of cars? What is your idea? One answer please. Increasing, you raise your hand. Cost of cars are increasing. Decreasing? Okay, no opinion also, there are plenty. So it doesn't matter. But general feeling today is car cost is actually decreasing. The mobile phone cost is actually decreasing. Television cost is actually decreasing. Phone call costs are decreasing. The costs are actually decreasing. So every day the automobile sector works on the principle of producing the same item at lesser cost than yesterday. So this is a challenge in automobile industry. If they don't reduce the price, they don't survive. But doesn't mean that the high-end cars are not increasing. High-end cars are always increasing. Whereas the moderate segment, which you say affordability segment in cars, is always decreasing. That means today more and more people are able to afford cars than yesterday they were capable of. That is called the price reduction. Compared to your ability to procure, the cars are more available. And you can afford to change the car more frequently than it was possible 10 years back. That is ability today. So actually the price of every commodity is actually coming down. Do you agree? You may not agree, maybe have political views otherwise. Doesn't matter. But what I want to tell is, engineer's job is to find out methods by which the price of every item or the cost of producing every item is every day reduced. And if you find the reverse of the trend, then you are no longer engineers. Okay, so this is another big challenge. I am not describing so much because a lot of methods are there to reduce cost in a process called product line rationalization, product integration, quality, smart manufacturing. I urge you take some special courses in this college. Otherwise, there are online courses which you can take, and like smart manufacturing, how to do, automation in manufacturing, So robots in manufacturing, product line integration design, lean manufacturing. Anybody heard of these words? Please read. Reusability is one of the important issue that rockets people are facing. Like aircraft, we are not using rockets. We used only once. We built such a complex machine. It puts one satellite, entire thing falls in sea. Whereas an aircraft, you take it for hundreds of flights. So it is economical, and we people are able to travel in an aircraft because it is reused. And the day it comes, rockets are becoming reusable. We should be able to travel in a rocket to moon and come back. So we are waiting for such thing to happen. Today, the possibility of reuse in rocket has been shown by SpaceX. Have you seen their reusable rocket? Any time in a video? Not seen. Please go and see. So this is the Merlin engine what the SpaceX builds, and this is the engine. It's a semi-gravity engine what the Blue Origin, the Amazon owner, is building. And the new engine of SpaceX which will take you to Mars. So they are working on every new engines today, and they are bringing to reduce cost from 10 million to 1 million type of engines. Earlier these engines used to take 10 million per piece. Now it is only 1 million. They are able to produce such engines. That means every day they are finding out technologies, materials, manufacturing process to bring down the cost. That is a challenge in engineering area. So another technique of reducing cost is reduce number of parts. So when you integrate various parts into single item, your cost comes down. Like that's why the molded chairs are cheaper than assembled chairs, because it is a single part product. So if you make it out of multiple parts, you have cost of assembly, nut, bolt, then different dies, and process time increases. Another important manufacturing technique today which has come is called additive manufacturing, 3D printing. Heard of this word? Okay, 3D printing is a process in which the material is deposited in various ways. It can be powder, it can be laser induced molten metal, or different layer forming, E-beam melting. There are so many technologies which are coming. Maybe some of you should take some seminar course in additive manufacturing. Plenty of literature available, and this is going to change the world in next 10 years. Entire items that you are going to handle in future in your home, in your office, in your engineering will be additively manufactured. Your dress will be manufactured additively. You can't imagine that no longer the stitching will be done in any shop. Your dress will be printed from material just like that with no stitching. All your shoe will be additively manufactured based on the custom design of your leg. You put it inside for a scanning machine, it scans your leg, and through the other end a printed shoe which is based on the design you have selected on the screen will come out. It is not far away. Your food, your burger you order in a McDonald's will be printed and supplied to you in the layers you wanted them to sequence. You can put a ham or cheese or the whatever layer you want, that will print and then give you the burger like that. Your heart will be printed using cells extracted from your own body, and that can be replacing your organ and bones and devices. Anything can be printed. So this technology is slowly making inroads into the way we people are looking at manufacturing. It's not all the machines that you are using called milling machine, lathe, all will vanish. Everything will be only 3D printing machines. Please watch for the day. So reusability I already described. So let me talk about some new developments and our strength. So I told about 12 years that you take to develop rockets in ISRO. So we wanted to make a change in this because world is changing. Cost is coming down, time is coming down, so we thought we will design a rocket in 1.5 years. So we designed a rocket called SSLV, Small Satellite Launch Vehicle. This is a 4-stage rocket. It is twice the size of SLV-3 of Kalam's era, and we have completed the design in 6 months. And we have manufactured, I am just seeing my WhatsApp, the first picture of the motor case manufactured has come in less than a year. And in 1.5 years to 2 years, we are going to launch it. Can you imagine that from 10 years we were able to find out engineering solutions to do this in just 2 years. So that's a great achievement for an organization like us, which is a government organization, want to compete with the world and the private industries in launch market. So we are also doing various new things. This is SSLV I just described. We are also trying to do a vertical landing of a stage like the Falcon does. and we are also making a heavy lift launch vehicle which will take almost 10 ton to satellite orbit. So that is under design now. This is SSLV, which is what I already described, which is using all new techniques, cost reduction techniques. This rocket cost only 30 crores. The PSLV cost today is 230 crores. One PSLV cost 230 crores and this SSLV cost 30 crores. So you can understand the cost reduction that we have brought in the choice of material, manufacturing process, complex system simplification, things like that. This is the challenge of an engineer. And we are going to work on very interesting area called human space flight. So we are going to carry human beings to space and bring them back safely, of course. So this requires a lot of complex work on making a rocket which will take human rated and then make software and hardware which is failure tolerant. Suppose anything fails, it understands it is failed, it will reconfigure. Suppose a computer fails on board, it will switch that computer off and switch on the next computer and work automatically. If a control system fails, it will detect that it is failed, it will take alternate algorithms. If nothing is going to work, it will ask the crew to escape and go to the safe route, to escape and parachute it out. Everything autonomously. So the software which you are going to put in rocket will be fail-safe software. And we are going to develop a two-stage to orbit vehicle which is based on air-breathing engines. So this we have already tested and we are going to fly a winged craft, go to orbit, stay in orbit for 1 month or so, do some experiments, then come back and land in an aircraft like landing strip. And 2 months later in this July or August, we are doing the first mission of its landing experiment at Karnataka. There is a Defense Air Force base. We are just getting ready to do this experiment of landing. And we are developing very complex engines today, engines which can be throttled. Suppose if you have to come down and land, the current engines are not capable. We have to reduce the thrust progressively so that it will slowly come and land. So we need engines which can be throttled. And we are also making engines which can restart. So these two capabilities currently we have, so we identified these are very essential capability for us to make future rockets. So rockets will look like this. It will land on legs and then come land, and it will also carry out experiments. It will also carry winged crafts. So these are series of test flights which we are planning to undertake in the future to enable us to carry the missions further. So this shows one of the craft. This is a winged craft. It will go to orbit. From orbit it will come back and land here. This is a takeoff. So this is the winged craft which is put on top of a regular rocket. So it's a funny arrangement. Nobody has done this before in the world. So we are trying to do such interesting missions. We are also trying to use balloons as landing platforms. So after reaching the orbit, this balloon will expand as a decelerating wing and it will come through the air and land softly, and then we can recover the experiment. So this is one model we have realized. We are going to make a launch, and very, very difficult thing to understand and study and make it work. So very novel idea is called aerodynamic decelerator, it is called. So we are going to test something like that instead of a parachute. This is a very interesting rocket. It is called Nano satellite launch vehicle. So it will launch very small satellites, something like 5 kilogram. You people, college students, are making a satellite. You want to launch the satellite and you want to do very cheap. You don't have so much of money, and you can allow students to launch that satellite using our nanosat launch vehicle. This is a launch vehicle we are designing using our available small rockets. So this currently the design is getting ready. We hope to launch in another 1 year. We are working on hybrids. I don't know whether you have heard about hybrids. Solid rocket you have heard, liquids you have heard. But solid rocket's problem is if you ignite it, it will have to fire forever and doesn't shut down. So hybrid rocket is one where the oxygen is kept separately, and I can inject the oxygen into the solid and it will fire, and if you want to switch off, I simply close this valve. So a solid rocket fires like a starting and restarting type of engine. So it has a lot of mission flexibility. So we have just tested one sample now, and we are going to develop a new rocket like this. So let me share my final areas with my experience that we have learned from mistakes. This is important for all engineers. In ISRO, we have a culture. If you make a foolish thing, or if you make a failure, or if you cause an error, we analyze it. We call it failure analysis. So I have a committee in VSSC called Failure Analysis Committee. Do you heard of such committees? So failure analysis committee is a very important committee in which multidisciplinary people will sit, they will analyze the failure, find out the basic reason why it failed and take the corrective action. So it's a multidisciplinary problem, not a chemical problem, not an electronics problem or a mechanical problem. It is a problem which has to be solved by people who have domain experts in various disciplines. So I will show you one example of such problems. So you know about ASLV3 and ASLV, probably you know. But this you wouldn't have seen. This picture is from ASLV failure. So it showed ASLV's first flight, it goes, it bends and breaks down like this. Fortunately, we were able to get photographs from at that time. So you can see the timing in 50 seconds to 50.55 seconds. Not even 1 second. This much has happened in less than 1 second. But we are able to get this many photos and we understood why it failed today. And we analyzed and found out what went wrong in this. And that has made PSLV successful. It is a very complex learning that we understood. It is because aerodynamics and control interaction takes place here. And this is the careful analysis of the data showed that. So this I will skip. And here again I will show you another problem. See, this is a thrust time curve of a solid motor. Thrust time curve means how much thrust is produced at any given time. But if you can see here, when such a rocket flies, it's the air pressure will be this much. But if I modify like this, air pressure will come this much. So when you do that, my rocket will be lighter. So if after designing it, we found it is this much. So our rocket hardwares are likely to fail. So what we did is immediately we changed the design like this, and the thrust time curve reduced and increased later when the atmosphere is not there. So it produced a rocket which is more efficient. Very simple principle. Maybe you won't follow this right now, so I will skip some of them. Another interesting problem we solved is when we were designing this GSLV Mark III, we found the bolts here we have designed in such a way in PSLV long back, but that principle cannot be applied here. We found in PSLV all the loads were compressive like this. F was always acting like this. But the moment forces act like this, bolt loads capacity has to be doubled because the force amplified to 2F on each bolt, whereas when in this condition F is equal to F here. Whereas when you apply force F and F, due to this eccentricity we have, the load multiplies into 2. So this was not understood and all our design has to be scrapped and made new after some level of understanding. Very simple mistake. So simply knowing that I know already PSLV, how to design PSLV, I applied it on GSLV Mark III and it caused a problem. So knowing too much is also a problem. I think you have to understand. So these are something which is very strategic, so I will skip. So this is about how to design a shape here. See, this is one of the rocket which I showed which is newly designed. So we found that if you make a shape like this, it will create flow oscillations. That air which is flowing through that will create such a vacuum here and it will oscillate and create problems. So we suggested it should be a boat tail so that this volume is reduced and can be modified. So this is one of the study that we did to understand how small things can cause problems. Another interesting thing is looking like a shark. This is the air breathing engine. So this was the original concept, but today it looks like this. So over the years this shape has continuously changed by various iterative analysis. So we have a lot of softwares with us which will study what all things can change and then understand and make continuous changes to create very complex machines like this. This is going to be our final air breathing engine. So this is a fuel tank and these are the gas tanks and the engine feeds, and inside there will be engine, control system, wings, air intake, etc. So all this very complex design is made already and we are currently under fabrication. Can you just click that video? Put up. I was a project director of this rocket. This was developed in the 2002 to 2014 time frame. So this was my first flight in December 2014, which actually sent the first human capsule to a suborbital flight, and we recovered it in the sea, almost 1,500 kilometers away from our launch station. So this was such a successful flight where we actually designed and developed this rocket to its fullest extent, and later 2 of these flights have happened, and now it is declared as an operational launcher which is going to launch our satellites. So this shows the next flight of it, which shows a pad abort test. Here also click, I don't think it works video. You can see this, how it fires. So this is the flight of a crew escape system. In case the human beings are put inside and it causes a problem, it can escape like this. It will immediately fire and take the crew 2 kilometers away from the launch vehicle which is about to explode. So it shows the parachute expanding and the crew module falling down with the parachute. You can see the bigger parachute coming out. Each parachute is 30 meters in diameter. So you can 30 meters is almost this much length, diameter is the size of these parachutes, and the weight of the craft is almost 4.5 tons. So it carries 4.5 tons and it impacts in sea so softly. So this design is the one which is actually going to take human beings to space. So this is one of the very innovative tests that we did in the recent times, and we are going to make the next one for the actual human being that is going to fly. It is still bigger in size that we are launched last time, so it looks so complex design. So what you saw firing is these motors with the reverse nozzles, these motors, and this is a place where the crew will be sitting, and this is a door where through which he will enter. So you can see this is the area where they are going to accommodate. It's as big as a big room where three of the astronauts can stay and then go to orbit. So in the future, we are going to look at economics, because ISRO cannot remain just like an organization which launches some interesting idea, but we have to make money. We have to be economically profit-making industry. We have to serve the nation in terms of the number of transponders and satellites. We have to meet the defense requirements. So last year we were given almost 20,000 crores of money from government to build all this, because our defense satellites, our servicing installations, our communication networks, our television networks, our imaging requirements are so huge today, and also the human spaceflight requirements requires also a lot of money. So this organization is now sufficiently supported by the government to handle all these complex engineering problems. And we are going to develop bigger rockets now. This semi-cryogenics engine is under design. This is a new engine which is going to develop 200 tons of thrust. And when you put it in the rocket, we are going to increase the payload capability almost 6 tons. And we are now currently in progressing designing new rocket which will have 10 ton to GTO capacity. We call it HLV, Heavy Lift Launch Vehicle. And this is how the human capsule will look like. This is a human capsule. This is a service module which will get attached and will get detached when it is returning. And later we will be putting some capsules where people can stay in the orbit for longer time. So what I wanted to tell you is a set of programs that we have envisioned in ISRO over the years, and we have set a system in place which includes technologies, management of the resources very well. And at least for next 30 years and long-term perspective of the planning of the organization is already done using our own people. And I want you to be aware of this part, that ISRO is not a place where some special people are coming from the world everywhere and then working. People like you, because I am also a student of a regular college. I got educated in a Malayalam medium school and had an opportunity to go to engineering college in a time where it was very difficult because entrance test was not there at that time when I went to engineering college. Because of that I went to an engineering college and became an engineer. Otherwise I would have never gone, I would have become a school teacher. So like me, ordinary people, ordinary engineers, not from IITs. No single man from IIT is there in ISRO. Very rare to find. Maybe few people were there. So people from local engineering colleges, NITs, they are the people who is building all this. So using our own indigenous knowledge, our own Indian people's skill, we are able to design and build very complex systems in this country and make India proud. So with that, let me say, we have an impressive array of rockets that are getting ready in the years to come. We were talking up to this now. So these are the rockets which are under design and development. So it's really exciting time for all of us in ISRO when you are designing new systems for the future. And I don't want to read any of this. What I want to tell you is that us engineers, I look at ISRO as a place which is very inspiring. It's a place where technology is working. We are not going to do some selling work. We are not going to become management or simple talk management. We are actually producing things. The engineers are having opportunity to work on core engineering issues, whether it is electronics, mechanical, production, manufacturing, and they are able to take up challenging assignments. Though we are in a government organizational system, we are able to actually produce. That's why ISRO is called as a very successful organization, and I am sure each one of you will be inspired by such successes, and this is something that we have to replicate in every organization and every place that we work. And be proud of this, what you have achieved in India, and we are also proud of the team ISRO, which includes at least 25% to 30% of young people like you. Every year at least 100 engineers, technicians, diploma holders, science graduates join ISRO. So I wish one day some of you will find a place there. Wish you all the best. Thank you. So let me put credits to some of the people who have been my mentors. All of them you are aware, so I don't want to explain. So at the end of this talk, I should speak about that. So I only want to speak about one person whom you don't know. This is my immediate boss for 20 years. Ramakrishnan, he is still there, ISRO. Dr. Suresh and Srinivasan are not known to them. But all these people are reasonably familiar to you, I think. So I won't explain of them. So in one of the quality of our organization is that we respect elders. And we always work together. Once this person who has been my boss for 20 years became a retired person, he has no difficulty in sitting in front of me. You can understand, I am sitting in his chair, he sits in front of me. And he asks me what we should do next. So this is the culture that we have. So we respect the position. We respect, irrespective whether, once a retired person goes, we normally don't like him, no? So that he has escaped from here and so it is my time now. So we don't have a culture like that. We mutually respect our seniors and we work together to keep our knowledge and skill intact. Because they have such a knowledge over the years and we need to understand how they can be utilized. So this is why I put the credit. Thank you.
So we have recently visited ISRO. So when we are there for... ഞങ്ങൾ ISROയിൽ ഒരു ഇലക്ട്രിക് വെഹിക്കിളിൻ്റെ ഒരു പ്രൊജക്റ്റിൻ്റെതായിട്ട് വന്നിട്ടുണ്ടായിരുന്നു. അപ്പോൾ ഞങ്ങളവിടെ വന്നപ്പോൾ ബിജു പ്രസാദ് എന്ന് പറഞ്ഞ സാറിനാണ് ആദ്യം കണ്ടത്. അപ്പോൾ ഞങ്ങൾ പറഞ്ഞു, സാറേ ഞങ്ങളിങ്ങനെ ഒരു AC ഇൻഡക്ഷൻ മോട്ടോർ വെച്ചാണ് ചെയ്യാൻ ഉദ്ദേശിച്ചത്. അപ്പോൾ ഞങ്ങളത് പറഞ്ഞപ്പോൾ തന്നെ സാറ് പറഞ്ഞപ്പോൾ നിങ്ങൾ എന്തുകൊണ്ടൊരു BLDC യൂസ് ചെയ്യില്ല? അപ്പോൾ ഞങ്ങൾ സാറേ കോസ്റ്റ് ഭയങ്കര കൂടുതലായിരിക്കും, ചെറിയൊരു ഇതിലേക്ക് കോസ്റ്റ് ഭയങ്കര കൂടുതലായിരിക്കും പറഞ്ഞു. അപ്പോൾ സാറ് പറഞ്ഞു ഇല്ല, പക്ഷേ നിങ്ങൾക്ക് ഒരു എഫിഷ്യൻസി വെച്ച് നോക്കുകയാണെങ്കിൽ BLDC ആണ് നല്ലതെന്ന് പറഞ്ഞു. ഓക്കെ, അപ്പോൾ സാറേ ഞങ്ങളെന്താ BLDC യൂസ് ചെയ്യാം. അപ്പോൾ എന്നാൽ നിങ്ങൾക്ക് എന്തോ ഒരു AC ഇൻഡക്ഷൻ. അപ്പോൾ ആ ഒരു കൾച്ചർ എങ്ങനെയാണ്? അപ്പോൾ ഞങ്ങൾ ചോദിച്ചു സാറേ എന്തുകൊണ്ടാണ്? അപ്പോൾ സാറ് പറഞ്ഞു ഞങ്ങളിവിടെ ISROയിൽ നിങ്ങൾ എന്തായിട്ട് വരുന്നോ അത് അങ്ങനെയല്ല, അത് അങ്ങനെ വേണ്ടാന്നൊരു രീതിയിലാണ് പറയണത്. അപ്പോൾ എന്നാലാണ് നിങ്ങൾക്ക് അതൊരു എഫിഷ്യൻ്റ് ആക്കാൻ പറ്റുള്ളൂ. അപ്പോൾ എപ്പോഴും ഒരു ഓൾട്ടർനേറ്റീവായിട്ട് ചിന്തിക്കാം. അപ്പോൾ ആ ഒരു കൾച്ചർ ഉണ്ടാവാനുള്ളൊരു
ഇദ്ദേഹം ചോദിച്ച ചോദ്യത്തിൽ കടുപ്പമുള്ള ചോദ്യമാണ്. കാരണം എങ്ങനെ നിങ്ങൾക്ക് ഇതുപോലെ കൾച്ചർ ഉണ്ടായി? അത് ഇപ്പോൾ നിങ്ങൾ ഓരോരുത്തരോടും ചോദിക്കുന്ന ചോദ്യം. നമുക്ക് ഓരോരുത്തരും ഓരോ കൾച്ചറൽ ആളുകളല്ലേ. ഇപ്പോൾ ചില നിങ്ങൾ പറയുമോ ഹീസ് എ കൾച്ചർലെസ് ഫെല്ലോ, ഹീസ് എ കൾച്ചർഡ് ഫെല്ലോ. സോ ദർ ഇസ് സംതിങ് കോൾഡ് ആൻ ഓർഗനൈസേഷണൽ കൾച്ചർ. ഇസ്രോയെ ഇയർമാർക്ക് ചെയ്യുന്നത് ഓർഗനൈസേഷൻ കൾച്ചറാണ്. അവിടുത്തെ ഫസ്റ്റ് ക്വാളിറ്റി എന്ന് പറഞ്ഞാൽ ഒന്ന്, പൊസിഷൻ ഒരു ഇഷ്യൂ അല്ല. ഇപ്പോൾ ഞാനും എൻ്റെ കൂട്ടത്തിലുള്ള ആളുകൾ എല്ലാവരും ആഹാരം കഴിക്കുന്ന ഒരേ ക്യാൻറ്റീനിൽ നിന്നാണ്. നമ്മൾ വർക്ക് ചെയ്യുമ്പോൾ നമ്മളെല്ലാം ഒരുമിച്ചാണ് വർക്ക് ചെയ്യുന്നത്. അതിൽ ഞാൻ ഡയറക്ടറാണ്, വേറൊരാൾ ടെക്നീഷ്യനാണ്. വി ഡോണ്ട് ഡിഫറൻഷിയേറ്റ്. പക്ഷേ നമ്മുടെ വർക്കിലെ ഡിഫറൻഷിയേഷൻ ഉണ്ട്. കാരണം അദ്ദേഹം ചെയ്യേണ്ട ജോലി എനിക്ക് ചെയ്യാൻ പറ്റില്ല, എന്നാൽ പിന്നെ ഞാൻ ഡയറക്ടർ ആവില്ല. പക്ഷേ നമ്മളൊരു പൊസിഷൻ ഈസ് നോട്ട് എ ഇഷ്യൂ അറ്റ് ഓൾ. പക്ഷേ നിങ്ങൾ പല ഈ അഡ്മിനിസ്ട്രേറ്റീവ് ഇഷ്യൂസിൽ പോയി കഴിഞ്ഞാൽ സിവിൽ സർവീസ് IAS ഒക്കെ പോയി കഴിഞ്ഞാൽ നിങ്ങൾക്ക് അറിയാം ഒരു ഹൈറാർക്കിക്കൽ പ്രോബ്ലംസ് എല്ലായിടത്തും ഉണ്ട്. രണ്ടാമത്തത് ആരുടെ ഒപ്പീനിയനും ഒരു വിലയുണ്ട്. ഇപ്പം ഞാൻ ചെയർമാൻ്റെ ഒരു റിവ്യൂ നടക്കുകയാണെന്ന് വിചാരിച്ചു ഹോളിൽ. ഞാനൊരു യങ് എഞ്ചിനീയറാണ്. ഐ വാണ്ട് ടു ഗീവ് സം ഒപ്പീനിയൻ. നമ്മുടെ സാധാരണ ഓർഗനൈസേഷനിൽ ഒരിക്കലും നടക്കില്ല. അവിടെ നിങ്ങൾ എനിക്ക് നിൽക്കുമ്പോൾ നിങ്ങൾ അവരുടെ ബോസ് അവിടെ ഇരിപ്പുണ്ട്, അങ്ങനെ സീനിയർ അവിടെ ഇരിപ്പുണ്ട്, എന്തുകൊണ്ട് അദ്ദേഹത്തെ പറയുന്നില്ല? നിങ്ങൾ അദ്ദേഹത്തോട് പറഞ്ഞപ്പോൾ അങ്ങനെ പറയുമായിരുന്നല്ലോ. അങ്ങനെ ഒരു ക്വസ്റ്റ്യൻ ചോദിക്കില്ല. ആർക്കും എപ്പോഴും ഒപ്പീനിയനും അയാളുടെ വ്യൂസ് ഷെയർ ചെയ്യാൻ പറ്റുന്ന ഒരു ഓർഗനൈസേഷനാണ്. മൂന്നാമത്തത് പഠിക്കുന്നതിനെയും മെറിറ്റിനെയും പ്രൊമോട്ട് ചെയ്യും. മെറിറ്റ് ഇല്ലാത്തവരെ പ്രൊമോട്ട് ചെയ്യുകയുമില്ല. അപ്പോൾ ഞങ്ങൾക്ക് ടൈം ബേസ്ഡ് പ്രൊമോഷൻ ഇല്ല. 4 കൊല്ലത്തിലാണ് നിങ്ങൾ അടുത്ത പ്രൊമോഷൻ ഇല്ല. ചില ആളുകൾ 10 കൊല്ലം എടുക്കും പ്രൊമോട്ടഡ് ആവാൻ, ചില ആളുകൾ കുറഞ്ഞ സമയത്തിൽ പ്രൊമോട്ടഡ് ആവും. മെറിറ്റ് ബേസ്ഡ് പ്രൊമോഷനാണ്. അതിൻ്റെ അർത്ഥം സ്കില്ലുള്ളവരോ കോൺട്രിബ്യൂട്ട് ചെയ്യുന്നവരോ ഏത് തരത്തിലാണ് നിങ്ങളുടെ മെറിറ്റ്. ചില ആളുകൾ ഹാർഡ് വർക്കായിരിക്കും നിങ്ങളുടെ മെറിറ്റ്, ചില ആളുകളുടെ ഐഡിയ ആയിരിക്കും മെറിറ്റ്. എല്ലാത്തരം മെറിറ്റുകളെയും പ്രോത്സാഹിപ്പിക്കുന്നുണ്ട്. അപ്പോൾ ഒരു ഓപ്പൺനെസ്. ഇപ്പോൾ ഒരു മിസ്റ്റേക്ക് നിങ്ങൾ വരുത്തിയാൽ അതൊന്ന് പറയുന്നവർക്ക് അവാർഡ് കൊടുക്കും. മിസ്റ്റേക്ക് വരുത്തിയതിന് അവാർഡ് കൊടുക്കും. കാരണം എന്ന് വെച്ചാൽ മിസ്റ്റേക്ക് വരുത്തിയിട്ട് അത് പറയാനുള്ള കൾച്ചർ ഒരു ഓർഗനൈസേഷനിൽ ഉണ്ടാകും. അതില്ലെങ്കിൽ ഫെയിലർ ആയിരിക്കും റിസൾട്ട്. അപ്പോൾ ഞങ്ങൾ എപ്പോഴും പറയുന്നത് ഇതാണ്, നിങ്ങളൊരു മിസ്റ്റേക്ക് വരുത്താതെ മനുഷ്യൻ സ്വഭാവമാണ്. എന്നാൽ അതൊന്ന് ഓപ്പണായിട്ട് പറയുക, ഞാനൊരു മിസ്റ്റേക്ക് വരുത്തിയെന്ന് പറയുകയും അത് ഓപ്പണായിട്ട് പറയുന്നവർ, ഞാൻ ഒരു മിസ്റ്റേക്ക് വരുത്തിയ ഒരാളാണ്, എനിക്കറിയാം എൻ്റെ കരിയറിൽ ആ സ്റ്റോറി പറയുന്നത് നിങ്ങൾക്ക് മനസ്സിലാവും. PSLVയുടെ C4 എന്ന് പറയുന്ന ലോഞ്ച്, അതായത് 4th ഫ്ലൈറ്റ്, അതിന് എൻ്റെ റെസ്പോൺസിബിലിറ്റി സാറ്റലൈറ്റ് അസംബിൾ ചെയ്യലായിരുന്നു. ഞാൻ യങ് എഞ്ചിനീയർ, മേ ബി ഒരു 5-6-7 വർഷം സർവീസുള്ള സമയത്താണ്. എൻ്റെ റെസ്പോൺസിബിലിറ്റി സാറ്റലൈറ്റ് അസംബിൾ ചെയ്യണം. അത് ക്ലീൻ റൂമിൽ ഞാൻ അന്ന് നൈറ്റിൽ ക്ലീൻ ഡ്രസ്സൊക്കെ ഇട്ട് ഞാൻ സാറ്റലൈറ്റ് അസംബിൾ ചെയ്യാൻ പോയി ഞാൻ അവിടെ അസംബിൾ ചെയ്യുമ്പോൾ 2 ചെക്ക് പോയിൻ്റ് ഉണ്ട്, അതിൻ്റെ ഹൈറ്റ് ചെക്ക് ചെയ്യണം. അപ്പോൾ ഒരെണ്ണം ഞാൻ തന്നെ പേഴ്സണലി ചെക്ക് ചെയ്തു, മറ്റൊരു വേറൊരാളോട് പറഞ്ഞു ചെക്ക് ചെയ്യണം. അയാൾ ചെക്ക് ചെയ്ത് പറഞ്ഞു ഓക്കെ ആണെന്ന് പറഞ്ഞു. ഈ റിപ്പോർട്ടിലൊക്കെ എഴുതി അസംബിൾ ചെയ്തപ്പോൾ എന്തോ ഒരു പ്രശ്നമുള്ള കാണാം. അസംബിൾ ചെയ്യുമ്പോൾ അത് ചരിയുന്നു. കുറച്ച് കഴിഞ്ഞപ്പോൾ ഒരു സൗണ്ട് കേട്ടു, വളരെ ഫീബിളായി ടിക്ക് എന്നൊരു സൗണ്ട് കേട്ടു. അപ്പോൾ ഞാൻ പറഞ്ഞു അതെടുത്ത് മാറ്റി നോക്കാമെന്ന് പറഞ്ഞപ്പോൾ സാറ്റലൈറ്റ് എൻജിൻ റോക്കറ്റിൻ്റെ സ്റ്റേജിൽ ഒരു പൈപ്പിനെ ഇടിച്ച് പൊട്ടിച്ചിരിക്കുകയാണ്. ആ ലോഞ്ച് നടന്നിരുന്നെങ്കിൽ ലോഞ്ച് മിഷൻ ഫെയിലറാണ്. അപ്പോൾ എനിക്ക് ആ സൗണ്ട് കേട്ടപ്പോൾ തോന്നി ഞാനത് ലിഫ്റ്റ് ചെയ്ത് നോക്കണമെന്നല്ല, ഞാനത് അസംബിൾ ചെയ്യാൻ പറഞ്ഞത് ബോൾട്ട് ചെയ്ത് അസംബിൾ ചെയ്ത് പോകും, പിന്നെ കാണാൻ പോലും പറ്റില്ല. അപ്പോൾ അന്നത്തെ ലോഞ്ച്, നെക്സ്റ്റ് ഡേയിലെ ലോഞ്ച് പോസ്റ്റ്പോണ്ടായി. അപ്പോൾ ആലോചിക്കണം, ജസ്റ്റ് ഒരു യങ് എഞ്ചിനീയർ കാരണം ഒരു ദിവസത്തെ ഷെഡ്യൂൾ ചെയ്തിരുന്ന ലോഞ്ച് പോസ്റ്റ്പോണ്ടായി. അടുത്ത 2 ദിവസം കഴിഞ്ഞ് ലോഞ്ച് നടത്താൻ പറ്റുള്ളൂ. എന്തായിരിക്കും എൻ്റെ കരിയറിൽ ഉണ്ടാകാൻ പോകുന്നത്? ആളുകൾ എന്നെ പിടിച്ച് ഫയർ ചെയ്യും, സാറ്റലൈറ്റ് നിങ്ങൾ നശിപ്പിച്ചു, റോക്കറ്റ് നിങ്ങൾ നശിപ്പിച്ചു, കൂട്ടിക്കൊണ്ട് ഇടിച്ചിട്ട് അല്ലേ. പക്ഷേ എനിക്ക് സംഭവിച്ച നേരെ എതിരാണ്. കാരണം അവർക്കത് മനസ്സിലായി എന്തുകൊണ്ട് ഞാനത് ഡിസ്മാൻഡിൽ ചെയ്തു, എന്തുകൊണ്ട് ആ എറർ ഉണ്ടായി. ആ മെഷർമെൻറ്റ് ചെയ്ത ആൾ ആ എറർ കണ്ടെത്തിയിരുന്നു. പക്ഷേ അത് റിപ്പോർട്ടിൽ എഴുതിയപ്പോൾ അതിൻ്റെ സിഗ്നിഫിക്കൻസ് മനസ്സിലാക്കാതെ എഴുതി. എൻ്റെ ഒരു അസിസ്റ്റൻ്റ് ആ സിഗ്നിഫിക്കൻസ് വെളിയിൽ നിന്ന് മനസ്സിലായിട്ട് എന്നോട് കമ്മ്യൂണിക്കേറ്റ് ചെയ്യാൻ ശ്രമിച്ചിട്ട് അദ്ദേഹത്തിന് ക്ലീൻ റൂമിൻ്റെ അകത്ത് കയറാൻ പെർമിഷൻ കൊടുത്തില്ല. അല്ലെങ്കിൽ അങ്ങനെ ഈ അസംബ്ലിക്ക് മുമ്പേ എന്നോട് ഒന്ന് പറയാൻ റെഡിയായിട്ട് വെളിയിൽ നിൽക്കുകയായിരുന്നു. അങ്ങനെ അറിഞ്ഞില്ല. ഇതെല്ലാം കഴിഞ്ഞിട്ട് ഒരു മീറ്റിംഗ് കൂടി, ചെയർമാൻ ISRO ഒക്കെ ഉള്ളൊരു മീറ്റിംഗാണ്. ഈ ഒരു ഫെയിലർ എങ്ങനെ ഉണ്ടായി എന്ന്, ഈ ഒരു ഇഷ്യൂ എങ്ങനെ ഉണ്ടായെന്ന് ആലോചിക്കാൻ. അപ്പോൾ എൻ്റെ ബോസ് എൻ്റെ അടുത്ത് വന്നിട്ട് പറഞ്ഞു, യു മേക്ക് എ PowerPoint പ്രസൻറ്റേഷൻ ഹൗ ദിസ് ഇഷ്യൂ ഹാപ്പൻ. എന്നിട്ട് പ്രസൻറ്റേഷൻ ഉണ്ടാക്കാൻ സമയത്ത് പുള്ളി എൻ്റെ അടുത്ത് പറഞ്ഞു, നീ പ്രസൻറ്റ് ചെയ്യേണ്ട, ഞാൻ പ്രസൻറ്റ് ചെയ്യാം. യു ക്യാൻ അണ്ടർസ്റ്റാൻഡ് ദ ഡിഫറൻസ്. അതായത് മിസ്റ്റേക്ക് വരുത്തി എന്നെ പ്രൊട്ടക്റ്റ് ചെയ്യാണ് എൻ്റെ ബോസ് ചെയ്യുന്നത്. അദ്ദേഹമാണ് ചെയർമാൻ പ്രസൻറ്റ് ചെയ്യുന്നത്. പ്രസൻറ്റ് ചെയ്ത ശേഷം അപ്പോൾ ചെയർമാൻ ചോദിച്ചു, ഹു വാസ് ഇൻ ചാർജ്? ഞാൻ എഴുന്നേറ്റ് നിന്നു. അതിനു മുമ്പേ പറഞ്ഞു, നിങ്ങൾക്ക് ഇന്ന് കിട്ടാൻ പോകുന്നത് ഏറ്റവും ഭയങ്കര ഫയറിംഗ് എന്നാണ്. പക്ഷേ കസ്തൂരംഗൻ എന്ന് പറയുന്ന ചെയർമാൻ, ഇന്ന് ഞാൻ വളരെ ക്ലോസ് ആയിട്ട് ഫ്രണ്ട്ലി ആയിട്ട് ഒരാൾ, അന്ന് ചെയർമാനാണ്, അദ്ദേഹം എന്നെ ഒന്നും പറഞ്ഞില്ല. അടുത്ത 48 hours ഞാൻ ഉറങ്ങിയിട്ടില്ല. ഞാൻ 48 hours കൊണ്ട് ആ സിസ്റ്റം മുഴുവൻ കറക്റ്റ് ചെയ്ത് 48 മണിക്കൂറിന് ശേഷം ഞാൻ തന്നെയാണ് നിന്ന് ആ സാറ്റലൈറ്റ് അസംബിൾ ചെയ്തത്. എന്നെ ആ പൊസിഷനിൽ, നീ കഴിഞ്ഞ പ്രാവശ്യം അസംബിൾ ചെയ്ത് മിസ്റ്റേക്ക് വരുത്തിയതുകൊണ്ട് ഇപ്രാവശ്യം നീ വേണ്ട, വേറൊരാൾ അസംബിൾ ചെയ്യാൻ ആരും പറഞ്ഞില്ല. ഞാൻ തന്നെ അത് അസംബിൾ ചെയ്തു, ഞാൻ തന്നെ അത് കറക്റ്റ് ചെയ്തു. അത് ISROയ്ക്ക് മാത്രം കഴിയുന്നൊരു കൾച്ചറാണ്. ഇതാണ് ആ കൾച്ചറിൻ്റെ വ്യത്യാസം. അതായത് ആളുകളുടെ മെറിറ്റിനെ സപ്പോർട്ട് ചെയ്യാനും അവരുടെ മിസ്റ്റേക്കുകളെ ടോളറേറ്റ് ചെയ്യാനും അതിനുള്ള കറക്ഷൻസ് വരുത്തുന്ന കമ്മിറ്റ്മെൻറ്റിനെ ആദരിക്കാനും കഴിയുന്ന ഒരു കൾച്ചറാണ് ISROയ്ക്കുള്ളത്. അതുകൊണ്ടാണ് സക്സീഡ് ചെയ്യുന്നത്.
സ്പീച്ച് ആൻഡ് ടൈം ഷോട്ടുള്ള സാർ എനിക്ക് ഇന്ന് ബിടെക് മെക്കാനിക്കൽ കഴിഞ്ഞാണ്. IISc ബാംഗ്ലൂരിൽ നിന്നാണ് MTech കഴിഞ്ഞ് ആൻഡ് ഓൾസോ വാസ് ഡൂയിങ് റിസർച്ച് ഇൻ IIT മദ്രാസ് ഓൾസോ. സാറിന് ഇത്രയും ഒരു ബാക്ക്ഗ്രൗണ്ട് പറഞ്ഞാൽ ഒന്ന് മാത്രമേ ഉള്ളൂ. And it was such a wonderful time for all of us, and please let us work together also. So thank you very much, and we will have a great time.